Everybody want to be a buddy, dude. Right. So nobody will lift this heavy ass weight. Go! I do it, go! Yeah!
So, as Ronnie Coleman, the father of bodybuilding, just showed us, muscle contraction could be a very easy task or it could be a very hard task. Sometimes we don't even think about doing it. But have you ever wondered why muscle contraction actually happens? Oh, sorry. But did you know muscle fibers actually have a hierarchy of organization, starting with the whole muscle, then going down to muscle fibers. Within muscle fibers, there are groups of myofibrils, and each myofibril is made up of sections called sarcomeres. These sarcomeres are what allow the muscle to actually contract. Each sarcomere contains myosin and actin, which are the thick and thin filaments.
Hold up. Myosin is a protein that actually makes up the thick filaments and contains two golf club-like heads, which participate in the power stroke. The power stroke will later be explained in the contents of this video. Actin composes the thin filaments and contains myosin binding sites and is a helical structure. More on this later. Within the sarcomere are two overlapping structures called the thick and thin filaments. The thin actin filaments are connected to a structure known as the Z line. The thick myosin filaments, anchored by the M line, pull the Z lines closer together. This shortens both the I band and the H zone, while the A band remains the same.
Before contraction can take place, there are a few very important steps that have to occur. First, the action potential must propagate down the motor neuron, stimulating the muscle fiber at the neuromuscular junction. This causes the muscle cell to become depolarized, commonly known as the motor end plate potential. The action potential will then propagate down the muscle fiber and down the transverse tubule, causing a change in voltage and the separation of the diiodopyridine and ryanodine receptors, causing the release of calcium from the sarcoplasmic reticulum into the cytosol.
Calcium plays a very important role in muscle contraction. On the actin filaments, there's this complex called the troponin-tropomyosin complex, which covers the myosin binding sites on the actin filaments. When calcium binds to troponin, it slides the troponin-tropomyosin complex off of the myosin binding sites.
Now, after the myosin binding sites are exposed, the myosin is able to bind to the actin, resulting in a cross-bridge formation. The myosin heads are able to bend and shorten the sarcomere, an action known as the power stroke.
It is important to remember that cross-bridge cycling has to occur multiple times. Cross-bridge cycling is the action of forming the cross-bridge, undergoing the power stroke, and then breaking the formation in order to contract the muscle or further relax it. Drop down and give me 20!
And remember, ATP is a very important part of cross-bridge cycling. In order for the myosin to detach from the actin, ATP comes up, detaches it, and then is hydrolyzed by the ATPase site. This then charges the myosin heads for future cross-bridge cycling. And if you want to test out your muscle contraction, make sure to go to Sensei Brague's Goshin Jutsu Karate Dojo, link in bio.